Okay. Welcome to Dixon's virtual Munch and Learn. I'm so glad you're here. Please take time to mute yourself if you're not already muted. I wanted to let you know that we are recording this presentation and it will be added to our YouTube channel. Please subscribe to our YouTube channel. You can find videos of art and horticulture and activities at dixon.org and on the Dixon homepage of our website. During the talk, if a question comes to mind, just go ahead and click on the chat button at the bottom of the screen and type in your questions, and then there'll be time for Mike to answer your questions at the end of the talk. And I guess I will read them to you, Mike. And so with that, let's introduce our speaker. Today's speaker is Mike Hansbrough. He's the area resource biologist for the Natural Resources Conservation Service, the NRCS, and that's a part of the U.S. Department of Agriculture. Mike grew up in Virginia in the Shenandoah Valley near his grandparents' farm. He attended Virginia Tech and the University of Tennessee at Knoxville. He has worked for the Forest Service, the TVA, a nonprofit conservation group, and has been the area biologist for the USDA-NRCS in West Tennessee for 20 years. He is the co-author of 2 University of Tennessee publications on native grasses. I believe one is Native Warm Season Grasses, the ID, Establishment, and Management, which is something that I'd like to get my hands on. So he's received a Tennessee Wildlife Professional Award. He was the Wildlife Conservationist of the Year for the Tennessee Wildlife Federation, and he received that award for outstanding contributions to the responsible use and management of Tennessee natural resources. So Mike has some interesting stuff to talk about. He has one of those jobs that we all wish we had, I think sometimes, maybe not on rainy days, but anyway, without any further ado, I'll give you Mike Hansbrough.
All right, well, thank you so much for everybody involved and for inviting me to talk to the group. I've got a fun presentation. I hope it's going to show you a little bit about, hopefully tell you a little bit about the Natural Resources Conservation Service. Many of you may know a little bit about the Natural Resources Conservation Service, but I'm going to try and share my screen right now. Let's hope that this, I'm going to go share screen number 2 and let's see if you guys see that. Everybody see it? Someone give me a thumbs up. All right, very good. All right, so I'm Mike Hansbrough. I've been out in West Tennessee for a while and really like it here, but I'm originally from Virginia, grew up in the Shenandoah Valley, hunting and fishing on around my grandfather's farm and on the Shenandoah River, and just have been part of the outdoors my whole life. And you're right, Dale, I've got one of the jobs I've always thought I might get, but really enjoy doing this type of thing. But I'm going to talk to you a little bit about NRCS, who we are, soil water resources, cover crops, and show you some other projects just to kind of give you some good examples of what's going on in Western Tennessee and with the NRCS. All right, so today's hot topic is NRCS and cover crops. That's me doing my thing. In about a couple of months, we do a lot of prescribed burning. A little bit of the training. It's great for these old field native grasses and reinvigorating pollinator stands and early successional cover. One of my favorite picks. It was on a training and I was just walking up and somebody with a camera got this shot as I just turned around and later gave it to me. But a little bit about our background. You guys have probably heard of the Dust Bowl and the Dust Bowl era. Well, the NRCS was first formed by the Soil Conservation Service in 1935 by Congress, and it was during those Dust Bowl days, and there literally was a cloud of dust that went in from the Midwest and settled in on DC. Now it's hard to imagine a cloud of dust and erosion being so bad in the 1930s that dust would travel in a storm from here to Washington, DC. But it did. And at that time in 1935, on April, Congress recognized that the wasting of soil and moisture resources on farm, grazing, and forest lands was a menace to the national welfare of the country. And that's when they established the Soil Conservation Service. And most folks know as kind of the old SCS, and I still get folks wanting to call us the SCS. But in 1994, we changed the name to the Natural Resources Conservation Service because we're more about soil. We're about many other things. So that's when the name changed. And if you Google us, and everybody likes to Google, this is where you get your information. This is our national web page. There's a lot of resources, a lot of information, but just Google USDA-NRCS, and you'll start finding all sorts of things. And if you see in the right-hand corner underneath popular topics, where you get financial assistance, they'll start talking about programs, technical assistance, and the field office tech guide. I'll get a little bit into that in just a little bit, and soils and plants and animals. So there's a lot of just great resources at our USDA-NRCS website, and I encourage you after this to check it out sometime. And we've got a lot of really interesting stories. Right there is a lesser prairie chicken. I've held in my hands a greater prairie chicken, but the lesser prairie chicken is, and that's it in display on some of the lakes and some of the breeding habitat. It's got a purple sac. The one I had in my hands had an orange sac underneath its eye on its throat. And those are on the booming grounds, and they're trying to breed. And it's an interesting story. But here's where some of you might, in relative to today's topic, might want to go down to the bottom part of the website. That first page, I just couldn't quite fit it on here, and so you can see it in a Zoom meeting. But click on that little unlock the secrets of the soil and about soil health, because that really is fits very much into our topic today. And there's so much good information on that section. There's so many good experts within USDA talking about cover crops and soil health, and those are one and the same. So a little bit about some of our partners, because some of you might have had some dealings with NRCS through our soil conservation districts. Those were formed shortly after Soil Conservation Service in 1935, but the districts came along 2 years later in 1937, and it was in response to this massive amount of soil erosion conditions. And the very first district was formed in North Carolina by Hugh Hammond Bennett, who's really called the father of the conservation movement and of the Soil Conservation Service. But this today is still one of our strongest conservation partnerships. And you have a Shelby County Soil Conservation District. You have a Fayette County Soil Conservation District. You have a Lauderdale County Conservation District. And those districts work very hard with the participants in those counties to give them technical information, point them in the right direction. They're working out of the same USDA office. Sometimes they hold tree days where they give away free seedlings, and they do a lot of great things for the community. All right, so some of our things that we use to help promote ideas and techniques to adopt cover crops and other conservation practices. We might, there's a lot of technical financial assistance for our landowners and for our participants, but sometimes we do field days, farm tours. We sometimes break out small groups. We have the partnerships like with the Soil Conservation District. Sometimes we have these trainings. Sometimes we do technical demos like the rainfall simulators and soil health kits like mile and no-till field days. And then also we support the research, both university and cooperator on the farm. And you'll see a little bit of that today in some of the data I'm going to present. All right, some general soils information, because I want to kind of build a little bit of soil knowledge before we get into some of these things and kind of build into why things happen and what's going on and how does cover crops, no-till really help our farming landscape. So soil in its very basic properties is made up of organic matter, which is usually a very small percentage, is right there at the very tip top of the surface. Minerals make up a majority of it, water, then the air spaces. So all this is really important for that water infiltration on soils and the exchange of gases. It helps moderate temperatures. There's a lot of nutrients here, recycling of waste. All that is very, very good. So caring for our soil helps ensure the longevity of not only humans, but plants, animals. Without soil, without this living organism as a component, we would cease to exist. And in Tennessee, there's this thing where we have, well, all across USDA, we have this soil loss tolerance. And what that really means is that that's the maximum amount of soil loss over a year that certain soils can have and still retain production and still not totally erode to where they're losing production. It basically will maintain itself. So a lot of these soils have, and this sounds high, but 3 to 5 tons per acre of what's called a T value, meaning they can lose that on the topsoil every year. Some of it's part of a natural process, but a lot of it is certainly man-made. So I just want to introduce that soil loss tolerance. All right, so I want to get into how does soil erosion really happen? And this is getting into grab the magnifying glass, get on the ground, watch a raindrop hit. And this was what would happen. The first part of that is detachment of the soil particles in its basic form. That's where it's dislodged, the particles dislodged from the soil, be it a silt particle, a clay particle, or sand particle from the soil. Those are the three components of soils by the impact of the raindrop itself or by wind. And then the next part of erosion occurs is when it's transported. And that is either through moving wind or water. And if it's water, everyone's seen it, it's flowing, it's dirty water coming off of a field. If it's wind, you've gone across some bare ground, you get dust in your eye. That is, in its most simplest form, transport of a detached soil particle. Then there's deposition. It doesn't stay suspended forever. It's going to go somewhere. So that action can either be by wind in the form of maybe the dust storm, or it can be water-based. And clay and silt, they're carried great distances before deposition because they're lighter. And the larger component, sand, will be carried a very short distance and dropped out. And it's certainly seen more in a riverine system. So here's are some examples of some fast moving water on the landscape. And this is what we call creating classic gullies. Gullies by definition are something that happens from erosion, and they're no longer fixable by just simple farm equipment. Like you cannot take a disc and drive a tractor across this and fix this. This is heavy machinery. This is, if you're going to fill these in, you have bulldozers, track hoes, possibly dirt pans out there to get it level. And we fix these every single year. So a little bit about what those are. So now this is not to say there's a lot of erosion. Now I'm concentrating a little bit on farm, landscape erosion, property erosion. There's a lot of erosion that occurs from the buildings of roads, malls, shopping centers, other urban developments, tremendous amount. And I'm not picking on farmers or landowners. I'm just highlighting what we are doing as far as USDA. We're recognizing the problem in an agricultural landscape and how we fix things. So this is a good example of some channel erosion. And there's some stuff that happens naturally within some stream and river systems, like the bigger they are, the more powerful they are. But this is a picture in our area of something that's happened, and it's not a good thing. And the landowner applied for a cost share and for technical assistance. This is the first photo on the left is the downstream view of where this stream has kind of jumped out and started eating into the bank. Now, these are fairly large watersheds. You get a flood event, and you'll notice on the right side where that tree is falling down, the one thing that's missing there is trees. Now, this is all grass. This is not crop. So it's still eating into that fescue sod on the right that was just, it's not even a pasture. This is just a hay field that's mowed and hayed, a couple times a year, but it's still eating into it, especially on the left side. You can see where it's eating into it. It's causing a lot of silt and sediment to enter this stream. This particular project got funded because there's a Tennessee state fish that's an endangered fish in this stream, and that type of fish does not tolerate sediment. So this is the before. Take a real quick look at this, and there's the after. Now, this had such high flows, the engineers had to come in. We had to heavily rock this, and you see where the main channel, see my cursor right here, the main channel is out here, but this thing, when it jumped in a flood, it came in here and started scouring, and it would run over here and just keep scouring this on high flow events. But we're trying to get this back into the main channel, and on high flow events, these are some engineered jetties where it comes in here, breaks down to velocity, and this will be, again, there might be some deposition material that comes in here, but gets the stream back in its corrected action. And that's me on top of the rock there talking to our district conservationist, who's the one that really helps implement the cost share programs in here. But the stream came down in this way and focused in on this bank and started cutting and came back. So I thought that'd be pretty neat to see a little bit about, we're talking about field erosion, but erosion occurs in a lot of other areas. And the sediment gets in these water bodies. There's some tremendous amount of sediment. If you look at China, 1.6 billion tons of sediment per year. China loses about 18 tons per acre per year. The rivers in India, there's another big number, 1.5 billion tons per year. That's for the country. But look at just the Mississippi River. There's 300 million tons per year going into the Mississippi River and losing it. Some of our best soils in the United States are right there in that Mississippi River bottom, and in the world for that matter. So sediments really are the number one pollutant for surface waters. They carry a lot of nitrogen, phosphorus, pesticides, organic chemicals, heavy metals. You have some mercury problems in some rivers in Tennessee, and they can destroy aquatic habitats. Like I was talking earlier, that one fish was actually a mad tom, and that's a small catfish that is only about this long at adulthood, only about 4 or 5 inches long. It's only found in certain waters, but it can also just make the water murky. There's the photosynthesis. You can get less dissolved oxygen, and so you get into a hypoxia kind of thing, which is what's happening out in the Gulf there in Mississippi. There's a large Gulf hypoxia, and I've seen some presentations where it's talking about the source of some of that, and some of the sources of sedimentation are coming right here from Western Tennessee. All right, some of our water quality data, I'm going to throw some numbers out here just to give you kind of idea of some of the landscape level of this problem. 4.75 million acres are cultivated, and that's about 17.6% of the total area here in Tennessee. Average cropland soil loss is around 3.6 tons per acre per year. There are 60,000 stream miles in Tennessee, 24,000 plus are impaired. That's about 41%. And there's different types of impairment, but about a little over 5,000 stream miles are impaired by just sediments. So 21% are impaired just by sediments alone. So that's a pretty big number, and I think that's a fixable thing. Some counties in Tennessee, this is how can cover crops and managing soil, but just recently, some counties in Tennessee were over 40 inches above normal precipitation in 2018. 2018 was a really, really rainy year, rainy summertime. Just 40, there's places when I've visited for trainings in Montana and the western states, they get 18 inches of rain total. Just that's it. They have to grow crops on 18 inches. We were 40 inches above our normal rainfall, depending where you are. That's somewhere around normal rainfall is 45 to 50 some inches, a lot of our areas. So most conventional fields, when I say conventional fields, those are ones that are tilled up, they're disking, they're do-all, they're working the ground up. That's what we call conventional tilled field. They handle on infiltration less than 1 inch per hour. So if you were to take, let's just say a cup, and you were to put this cylinder down over the soil in a conventional field, and you put 1 inch of water in the bottom of that cup, it would take an hour for it to go down into the soil. That's an incredibly long time. So you can see on rainfall events, if it rains more than 1 inch per hour, where's that going? It's runoff. And that's going back to that slide, building this kind of baseline of knowledge. That's where we get erosion, rain hitting soil particles running off. So, and it also seals over when they disc it up. And if you want to try this at home, go out there and just pour some water over some disc ground. People will disc ground and say, well, I want the rain to, I've got to work up my garden. I gotta make sure that the rain will go in there. Actually, it's the opposite effect. You disc it up, you destroy those soil particles, and rain will not go in nearly as fast as like a no-till field. And this is where you're gonna see the 2 to 3 inches per hour rate on no-till fields. Those are no-till planters. That's not disking. Then most soil health fields after 2 years of cover crops is greater than 4 inches per hour. So we're getting 4 inches per hour of infiltration when you combine it with no-till. So that's a lot of water going down instead of going off the field. So, and it really, that greater than 4 inches seems to be where the erosion is just noticeably less. Most non-wetland forested areas, according to some sources, they're greater than 30 inches per hour. And that's where you get into some of the really almost virgin, if you will, soil types and soils where the infiltration, everything's perfect, is in forest types. So here's an interesting slide. And this is 1.2 inches of rainfall. I believe this is Madison County. So the middle part of this slide right here to the right is 2 years of cover crops. From here over is just no-till. It's not tilled, it's not disc, but this is no-till cotton. And they've been no-tilling for a long time, but this is a 1.2 inch rainfall. Look where the water is standing on top of the ground and running off on 1.2 inches of rainfall. You don't see anything. That's it. So the water's going in the ground. It's going to the root systems. It's available to those plants. And that's the take home message there. You don't have, and there was a point where they went ahead and did the whole field there on the lower right. Okay, a little bit quickly about the nutrient cycle. I thought this would be good. You have water, air on the left side going into the soil. The plant matter breaks down the residue on top, the organics in the soil, the decomposers are going to break down all that matter. And you're going to release some nutrients. You're going to store some nutrients, but it's released up through plants, absorbed, and just keeps going back around. And that's in the soil, not in that rocky substrate, but in the soil part. And a lot of this is really in that first, I would say the first 12 inches of most soil types are really, really important. All right, major soil health processes, talking, and I'm going to get a little bit into the weeds here, but it's just important. Less disturbance. Disturbance includes tillage, excessive nutrients, pesticides, traffic, grazing without a recovery period, anything that impacts the soil. When we have a lot of activity in the soil types, we can compact it. If we increase the cover is carbon, grass is carbon, leaves are carbon. You're starting to improve soil functions. So crop diversity, living roots throughout the year is very important to increase cover, increase diversity. So plant diversity is very important. And you'll see this a little bit more as I get into mixes, but there's a lot of root sugars that are available to microorganisms, but plant diversity in your cover crops, everything from the grasses through the broadleaves is very important. It's just diversity, having more diverse, more living roots throughout the year is going to help with that nutrient cycle. And that's really the take home point there. And some of these same things, minimum disturbance, maximize your soil cover, get the biodiversity that you need so that you have those living roots. Now, what are some of the short-term benefits of soil health? Soil health is, when I say soil health, I'm really talking about companion practices. We'll get into those in just a minute, but we're talking about cover crops and good farming. Weed suppression, soil erosion, water quality, soil temperature. Soil temperature, I got a really interesting graph on that. Forage, if it's grazed, a lot of people can put a cover crop out there in the wintertime, and then they can graze it, and that's helping the cover. That we love seeing that. Long-term benefits, reduced inputs. Inputs are fertilization, more weed control, chemicals use. Organic matter is going to increase, less compaction. Main big one in my mind is water infiltration and holding the water, the rain that you get in the summertime, not allowing it to run off is very important for these producers. So I want you to kind of understand the conservation language. I've got to and maybe go over a little bit of this because according to my wife, we all talk into a certain lingo within USDA. So I need you to kind of understand how we talk. But within USDA-NRCS, we have this conservation practice standards and support. So when we do something on the ground, it has a name usually. And these things are very defined, what access control is as a practice. And we call these practices. If you look down towards the middle part, we have brush management. If you're doing certain things to manage brush, that's called the practice brush management. So go all the way down, you'll see cover crop there at the very bottom. And this is straight off of our EFOT, Electronic Field Office Tech Guide. And this is the list of practices. And I want to kind of tell you, if you were to Google Field Office Tech Guide or EFOTG, you will see that. And this is what it's going to kind of look like when you get into our Field Office Tech Guide. You're going to have to pick Tennessee. And if I've got any time and someone wants to see how to pull this up exactly, I can show you how it's done. But you go to section 4, and that's where our conservation practice standards are held. And there's some really good information. All this on the right is information just on one practice, cover crop. This is all available to the public. It's what we use as planning as a reference, but you get our conservation plan, our conservation cover crop standard is this one. This is the conservation practice standard, the CPS. And you get into implementation requirement sheets, statement of work, and you get into some guides and some tables and fact sheets that are just really good. And I want to show you kind of those. This is the standard. And these things are very specific. They're science-based. And it defines, what is the cover crop standard? What does it do? Well, it's grasses, legumes, and forbs planted for seasonal vegetative cover. The purpose, right there's the purpose. It will reduce erosion from wind and water, maintain and increase soil health and organic matter content, reduce water quality degradation, suppress excessive weed pressure, maybe break a pest cycle, improve soil moisture use efficiency, and minimize soil compaction. Right there is the practice defined. Then you get into the fact sheets of here's what cover crops are. Here's some recommended seeding rates and dates for cover crops. Now these listed and these pounds are for the individual cover crop itself. These are not mixes. So when you look at annual lespedezas, airleaf clover, barley, buckwheat, cowpeas, these are what you plant by itself. If you're looking at just crimson clover, 15 pounds for winter cover, planted August 1st through October 15th. And you need to stay within these dates. You get outside of this and you're in no man's land. So this is what we have. We also have some information on mixes, and these are some of our recommended mixes. We got some fact sheets on there, and you can look through our implementation requirement sheet, and you can see what do I need to plant for my garden? What do I need to plant for my future corn crop or my soybean crop following corn? So you get into these really good mixes where we've already identified, you know, how much rye do you, if you're no-till drilling, when this says drill, this is no-till drilling. If you're broadcasting it, some people will actually put a cyclone seeder spreader on the front of their combine, and or their aerial seed. We have planes flying literally thousands of acres of this stuff. And there's a window like this that we can do that, where we fly a plane in on soybeans right before the leaves fall. It's when they start turning color. And so if we were to do this mixture broadcast, that means like we're doing an aerial seeding. So you'd have 26 pounds of rye, 26 pounds of oats, 14 pounds of Austrian winter peas. Not my favorite one to use on a cover that's broadcast because it's a big seed. It will come up, but some of the smaller seeds like these will do really well. Crimson clover, radishes, turnips, those are all mixed together for pounds per acre. So this is what you need. This total thing is what you need per acre to sow if you're sowing it by a plane. Now, if you're drilling it, you harvested your crop, you take a no-till drill, this is what you plant. It's just a little bit less. And we get a lot of times much better stands drilled. It's not saying you can't broadcast and get some pretty good stands, but timing of rain and timing of your broadcast is everything when it comes to broadcasting. And this also tells you a little bit about your carbon nitrogen ratio, which is very important. And we have figured out what these are, but we list what the CNN ratio is. And normal soil is around 24 to 1. That's 24 carbon to 1 nitrogen. So if you're composting, you're probably around 30. But the higher the ratio goes in carbon, again, kind of simplify this, it's more of nitrogen. I'm sorry, it's not nitrogen. Carbon is more grasses, leaves, that kind of thing, the vegetative structure. The higher your ratio is, the longer it's going to take. All right, here's some of our practices. And I was telling you a little bit, kind of explain what practices are. Conservation crop rotation, rotating your crops, using cover crops. We now know what cover crops are. They can be single species, planted like wheat after corn, or they can be this mixture of wheat, clovers, Austrian winter peas, radishes, turnips after corn. Then residue management, no tilling really helps. And then how do you manage that? And then potentially prescribed grazing. Those are all practices that we would plan with a farmer to help get better stands. And then other things that help in correlation to soil health are nutrient management, making sure you're taking care of your pests, making sure your irrigation water management is actually needed. So a lot of times this saves money. You don't need as much irrigation water if you've got infiltration. If you're going out there and disking and you're cultivating and you're dualing and you're planting your corn early, guess what? You're going to have to turn on that water forever because it's all running off in its simplest form. And we've got the science to prove it. We can go out there and put a test plot right on top of the ground and show you that it's not going in. All right, some new technology is also helping with our conservation and cover crops, and that's a controlled traffic pattern. There's some good precision ag stuff that's come out. There's some good people that really know how to apply nutrients and pesticides only where it's needed, and the use of bigger tires that distribute the weight. But when you have quality no-till mixed with this nutrient management, diverse crop rotation, prescribed cover crops, and you see the crimson clover, Austrian winter peas, and the grains, the cereal grains in there, with all this new technology, then you've got a real win-win. Some soil health highlights that you're probably asking, well, how much are we doing in our area? But just in West Tennessee, our activity is extremely high. If I was to tell you before I showed you this graph, I should have said, what would be a high amount of acres that had cover crops in Western Tennessee? Would it be like 10,000 acres or 20,000 acres? Well, we have obligated 152,000 acres in 2018. I need to update this slide. In 2019, it was 156,000. So this is a trend that's growing. It's growing because it's successful and it saves the farmer some money, and they're willing to do it because it's good conservation. All right, and we have some water quality incentives for Mississippi River Basin and our MRBI projects and our national water quality incentives. We've got counties in Western Tennessee that are part of this, but it's an overall projects kind of help with water quality in West Tennessee, a lot of partners. And so it's a really good overall effort from many, many different people. Why is this important? You know, it's if you see the good nodules here down here, these are nitrogen fixing nodules here. You see these good structure. You see how it's kind of it's like a dirt clod. It's holding together. You see the fibrous roots. These are good soil properties. And the things that are considered is the overall soil health processes, the short-term benefits, the long-term benefits, the challenges, and the economics. And for farmers and landowners to do this, it's got to be there's got to be some money in the game to make them either more efficient, make them a little bit more money, et cetera. So some key things here, again, I want to pound this in. Less disturbance is good. Increase the cover, increase the diversity, the living roots throughout the year. If you think of where we've come from, and after I've shown you some living roots, what happened 30, 40 years ago when farmers got done with the fall harvest? Well, they went out there with a disc and they disc it up, and they would disc the ground because they wanted to break up the ground. It was just some of the practices. That's just what they did. My grandfather did it on his farm, and in Virginia, everybody did it. And so you think about, when do we get a lot of rain? When does our erosion really occur in Tennessee? It occurs mainly in wintertime. We're getting these big rainfall events. You've got this bare ground out there. There's this crop field, 20, 30, 40, 50 acres at a time, 100 acres in some of these big counties. You're getting all this rain, and you wonder why we have, you know, so much sediment in our streams and rivers. It's not only because of, you know, cropping and what that's happened, but it's, you know, construction along rivers, banks, roads, et cetera. So the more we keep that out, the better it is for everybody. So keeping ground covers like this is a good thing. This is wintertime. He's got his jacket on. You know, that's a big daikon radish growing. He's picking it up. It's making a pore space, adding sugars to the soil. It's a very tall plant. These things have been hit by a frost. They're starting to die. And there's a real science to the benefits and knowing which ones to get and how to control it. And you know, if you're going to graze it, but the soil temperature and the water quality improvements. But look at that soybean crop. Look how clean it is. Planting green. So many of our farmers are planting green now. And they're in this upper right-hand corner where you see this corn strip. From here over, this was sprayed. We call it terminated 3 weeks prior to this. So we're allowing these covers to grow up, and farmers are some of the most ingenious producers and people around, because they can figure out, hey, if I put enough weight on this, I get these coulters running, I can clear this, I can run this through here. If I plant green and then it dies, look how much good cover you've got and how that's going to be so important for soil temperature later, but it's growing well. Soil temperature. Yield is most often affected more by hot and dry than cool and moist. It's hard to have the best of both worlds where you want, hot and moist. But it's also, you start thinking about drought protection program, and what these cover crops are. They're almost like a drought protection program. Planting warm season annuals in cool season conditions can lead to issues, meaning if you're planting when it's too cool out there, you need to let it warm up. A lot of this get in the field early is a little bit overstated, I think. But driving force is regulating soil temperature. Soil temperature. And here it is. This is a very interesting graph to most folks. So when you're less than 95 degrees Fahrenheit, somewhere between 70 and 95, 100% of the moisture is used for growth. Now, after you get above 95 and you get into 100 or so, very few, the very few percentages actually used for growth. You're losing 85%. We've seen in disc fields temperatures up above in this red zone in some counties. Hot July conditions. If you've got bare ground, you don't have moisture there, you've disc it up. Not only when you disc it up, you have water running off, but you're not retaining the moisture. So having these cover crops out there really helps protect the crop, because the soil is not so hot and you don't have that problem with bacteria. All right, again, reduce inputs, increase profit per acre. I like these slides. I want to keep this, you see some clover, but look at this. This is a crimper, and they're crimping down here in the lower right-hand corner. They're crimping this. That stuff is almost as tall as the tractor tires. They're crimping it, and they're going to plant into it. I'm going to go back to that. Do you think much weeds can come through this? Only the spot where the drill is going is usually where you get your plants. It really helps on the weed control. I've talked about this one already. Compaction is such an important part of getting good production. And we want to make sure that we don't have compaction. And a lot of people say, well, I know how to fix compaction. Well, here's how you fix it. No-till, long-term. Now this right here is pounds per square inch. This shows you that when they ripped a field, they took a ripper, a no-till ripper. I'm going to rip through that fragipan. I'm going to rip through it. I'm going to just take control of this field. Look what happens for a short term, there's a little bit of a gain, but right in here, but look at this, long term, it actually increases the compaction. as you go deeper. So you fluff it up and then you just increase the compaction, whereas no-till kept it right here. You never got out there and ripped it. It's counterintuitive to some farmers. They just can't believe it, but the data is the data. So potential challenges, initial seed cost, seed loan can be as high as $40 per acre. There's some cost share programs that they can apply for help on that. Pest pressure, slugs, snails, some insects. If you're planting behind certain things, too cool a season, too rainy, where you have a lot of slugs and other things out there. Plantability, be able to plant through it. You can see where this one, they're planting green and they drilled right through here. And they got a real good stand. So there's a lot of issues. Termination, aerial seeding, can be some poor stands if it's not done correctly. So it's not easy, but it's certainly something that's very doable. And I'm running short on time, so I just want to show you a couple of those befores and afters. And I'm going to go through this study really, really fast, but I want to show you just some 6 producers. We got some stuff where we're actually in the field using a 5-species cover crop mix. And you see the control here. This is an equation that shows you the microbial activity, the water extractable, meaning can plants take it, and building up the organic carbon and nitrogen. So when you see these numbers increase, it's a good thing. And if you see lucky control versus the treatment, look where it increased, how much difference is doubling in activity in water and organic carbon and nitrogen. So you get some very good numbers. We've got the data just in looking at some of these different numbers, how they're increasing. And this is using a lot of the Haney test. And I just want to show you where that's really increasing. The Haney test, you can Google that, figure a little bit more about that because I'm running short on time. Yield covers versus no-till systems. I think this is good. When you start putting cover crops down, everyone was thinking that they might have a yield drag, but when you understand the carbon nitrogen ratio and what you need to plant in preparation for, hey, corn uses up a lot of nitrogen. So after corn, for example, you would come in with a mix, a cover crop mix that is very high in legumes. Legumes fix nitrogen from the air into the soil. So you're trying to replace some of those soil minerals, and not minerals, but the properties of soils that allow the next crop to grow, and that's nitrogen. So they got a nice bump, 3 to 20 bushels per acre on corn using these, 2 to 20 bushels per acre on beans. This is all data that we have had from various different folks that have been in there. I'm going to fly through this, folks, because I'm running out of time. But value, do they make much difference? Absolutely. Especially when you're getting some of this free fertilizer. And we've had different types of rotations and things that we've tried in the field, in our area, summer covers, winter covers. There's a lot of good data out there that we have gotten in the last couple of years. Now on the program opportunities, we've got Environmental Quality Incentives Program, our Conservation Stewardship Program, and our Regional Conservation Partnership Program. But the EQIP and CSP are where a lot of people, especially EQIP, we've spent a lot of money over a short period of time, $12 million in 1 year, just for 152,000 acres. But when you start seeing covers like this over the landscape, it really makes a difference, folks. I've never seen anything now that we have done other than no-till that has changed maybe the agricultural landscape in Tennessee. The more people that are doing this, and we have a new study right now that's looking at, are we getting wildlife benefits out here? Do we have some nesting that's occurring after they plant, before they plant, successful ground nesting? So the future looks bright. We know we're getting erosion control benefits. Landowners are telling us, it's not us, but landowners, producers are telling us they're seeing production benefits. The UT study might prove additional wildlife benefits for nesting birds, and we're constantly working for opportunities on improvement. Conclusion, we tell producers, try not to get frustrated. This is a long-term commitment. You won't change this overnight, but little by little, no-till and cover crops, you're going to change it. And it needs to be changed. And you need to look at your objectives. Tighter margins for profit require adaptation, and maybe not everything's supposed to be cropped. You can certainly enroll some of that into wildlife cover. I've got some, if you Google some Tennessee Association of Conservation Districts, that's TNACD.org, Tennessee Association of Conservation District, look up soil health heroes, you'll hear it firsthand from the producers. There's many videos of producers in Western Tennessee talking about cover crops and how important it is for their farm and their landscape operation, really. All right, that's a picture from Obion County I took. And at this point, I'll take some questions.
All right, I've got several questions here, Mike, but I thought I would just real briefly talk about what we're doing here at the Dixon. During the pandemic this year, we decided we weren't going to plant any fall annual color. And so we have areas like the perennial border and other areas at the Dixon that we've been taking from the soil for so long. And I've always wanted to try some cover crops here in the cutting garden and in some other areas. And so we decided that since we weren't planting any winter annual color, that we could cover some of these areas with cover crops. And the main reason we're wanting to do this is to, weed control over certainly erosion is one thing, but weed control, sort of the soil health aspects of it, the green manure, we're going to till this stuff in before it goes to seed. And this helps sort of break up pest cycles. So you have these pests that sort of get established, especially when you're planting the same crop in the same area year after year. And so sort of breaking that up. And of course, Adam Queen on staff, he's all about the microbiology of the soil. And as you mentioned, a lot of these sugars that are exuded from these roots are very, very beneficial. So we probably won't see miraculous turnaround in doing this for one season, but we thought it'd be an opportunity to educate folks about cover crops. And I think they can be adapted to the home garden and certainly to the Dixon. More and more, everybody's concerned about the environment and the ecology of things. And I think cover crops are one way that we can address that.
Yeah, and I'm just clicking on the chat for a second. I saw a couple of questions. I'm going to address those real quick if you don't mind. On the cover crop mix is good for garden beds also, or are they just recommended for farms? Well, your garden bed is a miniature farm. So absolutely they are. And you're taking so much nutrients out of the soil every year, and to help with your weed control pressure, cover crops are getting a lot of use now, just starting in actual gardens, small areas. And they're sowing them in the fall with a mix. So you can look at some of our information and pick out a really good mix. One that would probably have a little bit of crimson clover, maybe have something like wheat. You can have some fun with it. You can mix it up and go out there and sow it in the fall after you've gotten all your crops, and let that be your source of infiltration for next year. I don't disc up my garden. I have a pretty big garden. Disking is over. I have been doing this for a couple of years now. It's great. I can walk out in my garden after rain and I don't even get muddy feet because I'm over top of stuff that's been laid there on the ground that's killed. So you can try this. It really helps with your weed control. You can have a little bit of weed in those sections where like corn's coming up. The weeds will get in between those individual stalks. But I don't fertilize as much on my garden. So you might want to try that and just try it and just learn. I think it's worth trying.
All right. Do you see the other questions there, Mike?
Yeah, so I don't get into too much of like the manufacturers, you know, like the equipment manufacturer. The equipment manufacturers out there are certainly out there to help farmers. You know, if we're just trying to tell people what's successful, equipment manufacturers certainly have a chance to sell more crimpers. Crimpers are good for the landscape. And there's guys in Western Tennessee that have driven all the way to Ohio to buy crimpers. So, you know, you got a local business that's not selling crimpers, they're missing out. And there's still a lot of folks that want to sell, you know, do-alls and things like that have a use for in bottomland fields that are not highly erodible. You know, if they have, if they want to not no-till plant in those type of areas. But I'm looking at muley grass. I don't really deal with that. I try and use the materials that are on our fact sheets, and what you're looking at is annual grains, something like wheat, barley, oats. Ryegrass is probably the one grass that can penetrate a fragipan and help break up the soil, but it's something that it needs to be terminated. It means it needs to be killed at shorter than 10 inches. We use a lot of ryegrass, annual ryegrass, to help break up fragipans. I've jumped down into soil pits where in 1 year the ryegrass had gone down 4 feet into a fragipan where no other soil root could go into. So it really helps. And knowing what you need to get into the fragipan helps. Living roots.
So no, I got a sort of, in West Tennessee, it seems we have these highly erodible soils. And in fact, I think every stream in Shelby County is 303 delisted by the Environmental Protection Agency because mainly it's turbidity, which means that it's mud in the water. And you know, you think of the Wolf River and the Mississippi River and all these things that, but our soil seems to be more erodible than most. Is that correct?
Yes, we have a lot of loess deposit soil, wind-blown soil from the plains. It's very, very silty. It melts like ice cream. You get a lot of bluff soils that are in, you know, northern Shelby County, Lauderdale, Dyer County, Tipton County. Those are some of the most erosive soils in the United States, right there on those counties. And they're just, I mean, literally the silt in those are just, they're so deep, and farmers have gotten away with farming those areas maybe conventionally because it's such deep silt. They go through another layer of silt, but they still have more production underneath of it. But in regards to our rivers, the forked deer and the bind were targeted by some research because they were leading silt, sediment, and I want to say it was had a lot of nutrients that led to or helped build up the Gulf hypoxia. They are major sources of some of those nutrients and sediment that we don't want to see end up in our, you know, going to the Mississippi River. So, you know, the Wolf River is one of those few still untamed rivers, and parts of that is good. But when you get into some of the stuff and some of the channelized systems, and you get around construction, and some of the sediment in it has entered the stream from a long time ago, and it's just still there. It's just flushing out. We have these sand bed loads that are just going to be there for a long, long time. It's not any easy answers. But the more that we can do now, I think, in reducing that and building up, you know, we're still trying to reduce sediment runoff, but we're also trying to build back the soil and make it more more productive for farmers raising fruits and vegetables.
Well, Mike, thank you for your talk. Thank you for your passion. You're a champion for the environment, doing great things out there, and we're trying to figure out how to bring this to the home gardener. So thank you so much for your knowledge and your passion. We appreciate you sharing that with us today.
Thanks for having me. I hope you enjoyed it.
Thank you so much, Mike. That was great. He left. Thanks, Dale. Thanks for hosting. I got into it as soon as I could. It was very good.
Thank you.
All right. See you later.